In this video, I want to show you a more detailed example of how a computer works. So we have here a made-up oversimplified CPU, and this CPU has two registers, R1 and R2. A register is like a memory cell where you can store information, and the CPU can operate with the data here. It has R1, R2. We have here the program counter, the PC. The program counter points to the next instruction the CPU needs to get from memory. Remember that the instructions, you have the instructions in the memory. And here you have the instruction are already fed by the processor. Here we have the memory, this is the memory. And something important about the memory is that you can't get individual bits from there. The memory has uh, has some addresses. For example, this will be the address number 3 in the memory. And when you recover that part of the memory, you are recovering all this data. This is what is called a word. And the word can have different length depending on the CPU architecture. In this case, our words will be 8 bits length, but today it's more usual to have 32 or 64. 64 is more or less the standard today. 64 bits for each word in the memory. So when you recover a position in the memory, you're recovering 64 bits. In this case, we have 8 bits here, and then we need to operate with this CPU. And the first thing we need to know is the instruction set of the CPU, because each CPU architecture has a different set of instruction, different things that it can do. For example, the Intel processor has some kind of instruction, and a mobile processor has a different one. So depending on the processor, you have a different set of instructions. Here, in this oversimplified computer, we have this instruction set. We have only 1, 2, 3, 4, 5, 6 instructions. Okay, here, and then uh, this is decided by the people who designs and builds the CPU. Here we have 6. This one is LR1. It's just an invented name. It could be whatever. It could be whatever. And this instruction, what it does is to read a word from the memory and store it in the register number 1. The LR2 is the same. It will read position of the memory and store it in the register number 2. It will add the two register, the contents of the two register, and store it in the register number 1. This is completely invented. It could be it could be different. JO, it will jump to a different memory address. It will keep running the program in a different memory address if there is an overflow in the add-in. STO, it will get the contents of R1 and store it in the memory, and Alt just will finish the execution. This is our processor. This is the instruction set, and now we're going to execute a program and see what's happening here.